Welcome you all. In this video session we will solve some of the numerical problems on the forced vibration. Okay, let us take this problem. A mass of 10 kg suspended from one end of the helical spring, the other end it is fixed. Here it is a mass, one end it is fixed and other end it is suspended of mass 10 kg. The stiffness of the spring, the stiffness it is 10 Newton per millimeters. You convert it to newtons per meters, so it is 10,000 Newton per meters. The viscous damping causes the amplitude to decrease 1/10 of its initial value. If initial value or initial amplitude is x naught, then after 4 complete revolution the amplitude will be 1/10 of the x naught, so that is 0.1 times of the x naught. Okay, after 4 oscillations the amplitude reduces to 1/10 of the initial value. If periodic force of 150 cos 50 t, okay, let us consider the forcing function, it is f naught cos omega t. If you compare with f naught cos omega t, then f naught it is 150 and omega is 50. Frequency of this mass spring system it is 50 radian per seconds, is applied at the mass with vertical direction. The load is applied with the vertical direction. So what is the amplitude of forced vibration and what is its value at resonance? Okay, here it is asked to find what is the amplitude of the forced vibration. We already derived the amplitude of the vibration, that is x is equal to x naught divided by square root of 1 minus omega by omega n square whole square plus 2 zeta omega by omega n whole square. So to find this amplitude, what is needed here? We need the frequency ratio. See here, okay, this is the equation to find the amplitude of the forced vibration. We need x naught and omega by omega n and zeta value. Okay, let us find what are omega by omega n, zeta value and x naught. What is x naught? X naught is equal to f naught divided by k. F naught it is given, x naught equal to f naught it is the given value, that is 150 newtons, and k value, spring stiffness value, it is given, it is 10,000 Newton per meter. So x naught value now it is known. Okay, x naught value it is f naught by k. Omega value, as the forcing function f naught cos omega t, it is given as 150 cos 50 t. So omega value, if it is compared with this equation, omega value is 50. So now we need omega by omega n. Omega n equal to square root of k by m. Okay, we have stiffness value and mass value, so omega n equal to square root of k by m. So omega n both are known. Okay, to find this amplitude, now x naught is known, that is f naught by k. F naught is 150 newtons divided by spring stiffness, it is given 10,000 Newton per meter. Omega value it is also given value. Omega n can be calculated by square root of k by m. The only unknown now, or we need to find is zeta value. How to find zeta? Okay, to find the zeta value, okay, here in the problem they have mentioned after 4 oscillations the amplitude, the original amplitude, it reduces to 1/10. Okay, we already know that in the logarithm decrement delta equal to 1 by n ln of x naught by xn. Okay, xn it is the amplitude after nth cycle. So here it is given that after 4 oscillations, so n equal to 4, delta equal to 1 by n, n means 4 after 4 oscillations. Okay, after 4 oscillations the amplitude, the original amplitude, that is x naught, the after 4 oscillation xn is equal to 0.1/10 of the original amplitude. So this x naught get cancelled. What we have, that is delta. Okay, by using delta equal to 1 by n ln x naught by xn, delta can be calculated. Delta is the logarithmic decrement. Okay, after finding this delta value, okay, we know that the relationship between logarithmic decrement and the zeta value, zeta equal to 2 pi zeta divided by square root of 1 minus zeta square. Okay, this zeta is required in our equation, it is the unknown. Okay, you just find this delta, that is the logarithmic decrement, that is equal to 1 by n ln of x naught by xn. Okay, there n is 4 cycles and x naught, it is keep as it is, and xn, that is after 4 oscillation, what is the amplitude? 1/10 of the x naught. So you substitute xn as 1 by 10 x naught. Okay, so this delta can be calculated. You use this relationship and find zeta value. Okay, then you substitute in this equation, we have all the values now, so you will get the amplitude of the forced vibration. Okay, after finding this amplitude, we need to find one more parameter there. Okay, what is its value? What is amplitude at resonance? At resonance, omega is equal to omega n. So omega by omega equal to omega n. So omega equal to omega n. So it is omega by omega n L is 1. So 1 minus 1, it is 0. This whole term get cancelled. So x naught by omega n, again it is 1. So the amplitude is x naught divided by 2 zeta. X naught divided by 2 zeta. You substitute this value and this is the amplitude at resonance. Okay, let us consider one more problem. Here mass is given 4 kg. It is in a viscous medium. Exciting force is 40 newtons and it causes a resonant amplitude. Resonant amplitude value is given 15 mm and time period it is given 0.2 seconds. So determine the damping coefficient. Okay, mass is 4 kg, harmonic exciting force it is 40 newtons and resonant amplitude. How to find the resonant amplitude? Resonant amplitude is x is equal to x naught divided by 2 zeta. X is equal to x naught divided by 2 zeta, where x naught is f naught by k. Okay, x is equal to x naught divided by okay 2 zeta, where x naught is equal to f naught by k. F naught value it is given here. Okay, x naught is equal to f naught by k. F naught it is given here 40 newtons and zeta value. Okay, zeta value it is not directly given. Okay, time period is given 2 pi divided by omega. Okay, 2 pi divided by this time period, it gives you natural natural frequency. 2 pi divided by time period gives you omega value. By this omega value you find the unknown stiffness. Then to find the zeta value, we know that x amplitude equal to x naught divided by 2 zeta. X naught is f naught by k. F naught is 40 newtons. K is determined here 3947 and zeta value can be calculated here, the zeta value. Okay, what is the thing here? We need to find the damping coefficient. Damping coefficient is c. Okay, we know that zeta equal to c by cc, where cc is 2m omega 1. So c equal to 2m omega 1 into zeta. We have already zeta value. Omega 1 equal to square root of k by m. Okay, mass value it is 4 kg. So we have the damping coefficient. Okay, if the system is excited by the harmonic force 4 Hz, what will be the percentage increase in the amplitude when damper is removed? When damper is removed means zeta value is 0. Okay, amplitude of, okay, let us, when it is excited with 4 Hz, so 4 Hz means 25 radian per second. So frequency ratio is 0.8. You substitute the frequency ratio 0.8 and zeta value is 0. So we have the amplitude Okay, it can be compared with the earlier